Hi, welcome to Azure with Mohsen. This is a 5-part short series where I highlight the key areas every cybersecurity architect must assess when reviewing an AI solution. Part 1 was the foundations. Part 2 was AI threat modeling. Today is Part 3, deep technical security, the controls under the hood that actually enforce security. Quick recap. In Part 1, we covered the 5 foundations: data security, model security, zero trust identity, API security, and monitoring. In Part 2, we covered key AI threat modeling, prompt injection, model poisoning, model extraction, adversarial inputs, and unsafe outputs. Now in Part 3, we translate those threats into technical controls, how the platform is built, deployed, and operated securely. Let's anchor everything in one real scenario again. Imagine a Teams AI assistant inside a large organization. It retrieves content from SharePoint or a knowledge base, send it to an LLM, and make calls to tools such as Microsoft Graph or ServiceNow. This architecture has multiple planes: the pipeline plane, the data plane, the runtime plane, and the tool plane. Deep technical security means securing all of them, not just the model. So what does deep technical security really mean? It means secure machine learning operations and software development lifecycle, SDLC, strong change control for prompts, tools, and models, runtime isolation and network controls, identity and secrets done properly, tool safety for agent actions, and finally validation, testing, and rollback. If you get these things right, you can scale AI safety. Let's start with secure machine learning operations and software development lifecycle. Your AI solution still goes through build, test, and deploy, but now your logic includes prompts, connectors, and data pipelines. So the basics matter. Separate dev, test, and prod environments. Require code reviews and approvals, especially for prompts, templates, and tool integrations. Scan dependencies and container images, and track provenance, who changed what, when, and why. This is how you reduce the risks, like accidental weakening of guardrails, and how you defend against supply chain issues. Next, model artifact security. Treat a model release like a software release. Use a model registry with RBAC. Version models. Promote them through release gates and restrict who can approve production. Encrypt model artifacts at rest, and most importantly, be ready to roll back to a last known safe version if behavior changes. Rollback is not optional in AI. It's part of operational safety. Now let's talk about the retrieval and vector database layer, the RAG data plane. This is where many AI apps fail in practice. You need permission-trimmed retrieval. The assistant must only retrieve documents the user is already allowed to access in the source system. You also need ingestion controls. What gets indexed, what gets excluded, and how sensitive content is handled before it ever reaches the vector database. Secure the vector store with encryption and RBAC, and prevent oversharing by controlling the number of retrieved chunks and applying filters. The principle here is simple. If retrieval is misscoped, the model can leak data without being hacked. Next, runtime isolation and network security. Secure models serving like any production workload. Use private endpoints where possible. Segment networks. Separate the app layer from the data layer and tool integrations. Apply egress controls so the system can't make uncontrolled outbound calls. And depending on your architecture, consider compute isolation, especially if you are running your own model workloads or multi-tenant GPU resources. This is how you reduce blast radius. Now, secrets, identity, and key management. One of the fastest ways to lose control is hard-coded keys in code or wide-scope tokens. Use managed identities or short-lived tokens wherever possible. Centralize secrets in a vault, rotate regularly, and scope access to least privilege. Also plan for privileged access, brick glass accounts, approvals, and time-bound elevation for sensitive operations. In AI apps, secrets often unlock tools. So secrets are not just infrastructure, they are capability. Next, tool and agent security. If your assistant can call tools like Graph API or ServiceNow, the risk increases significantly. So treat tools like production critical actions. Use an allowed list of approval tools. Scope tokens per tool and per action. Add user confirmation for high-risk steps. And apply rate limits and abuse protection. Now, validation. Because you don't trust the model output by default, you need input validation to detect suspicious patterns like jailbreak attempts. You need output validation to prevent accidental disclosure of PII or secrets. For critical answers, add grounding checks. For example, return links, citation, or source references instead of pure free text. And for regulated or high-impact use cases, keep a human in the loop for approval. This is how you reduce harm for hallucination and unsafe outputs. Finally, testing, red teaming, and continuous assurance. Don't wait for production incidents to learn what your model can do. Build a test suite for prompt injection, direct or indirect. Test abuse patterns like scrapping and extraction attempts. Use canary release to roll out changes safely. And have an operational rollback runbook. What triggers rollback? Who approves it? And how you restore the last safe model and prompt configuration. Deep security is not a one-time design. It's continuous assurance. So that's part 3, deep technical security. Secure pipelines, secure artifacts, secure retrieval, secure runtime, secure tools, and validate and test continuously. Next is part 4, vendor dependency, exit strategy, and data destruction. How to avoid lock-in and offboard safely. You can also read the summarized version on my LinkedIn. Thanks for watching.